In this video, we will understand about expression evaluation in C. In C, there are basically 5 types of statements: declaration statement, a statement having an expression, a compound statement, labeled statement, and a control statement. Declaration statement, it basically includes a name and type of a data objects that are required in a program. Expression is a combination of an operator and operands that yields a specific value. A compound statement is a group of statements that is considered as a single statement for execution. Labeled statement, it is used to mark a statement and to get a control to that point. Control statement, these determines the flow of execution in a program. They can be classified into selection, iteration, and jump. Selection, a particular execution path from a set of one or more alternatives. You select one particular statement to get executed. Iteration, a group of statements are executed repeatedly. Jump, it causes an unconditional jump from one point to another. So in this particular video, we will understand how the expressions are evaluated in C. An expression, as discussed, it's a combination of operators and operands. It yields a value. Now, how are these operators evaluated? There are basically 2 rules. One is precedence and one more is associativity. Now, these both determine the order of evaluation of these operators. For example, I have 4 plus 3 into 2. Now, how do I evaluate it? Should I add 4 plus 3, get the value, to that I need to multiply 2, or should I perform the multiplication of 3 and 2, to that result I need to add 4. So this ambiguity is resolved by the 2 rules, that is associativity and precedence. We shall have a look at these rules. The first one is precedence. Now, when there are more than one operators in an expression, there is a relative priorities of these operators which determine the order of the evaluation. Every operator has a precedence, has a priority. Right? Now that priority is called as a precedence. They are relative in nature, that is one operator has higher precedence than the other or lower precedence than the other. Okay, now let us go back to our previous expression, 4 plus 3 into 2. Right? As per C language, multiplication has higher precedence when compared to plus. Now this tells that 3 into 2 must be computed first. To that we need to add 4. So the resulting value will be plus 4. The result of this expression is 10. Right? Now there is one more rule. What if I have in an expression 4 into 3 divided by 2. Now as per the precedence, multiplication and division, they have the same precedence. That means if the operators of the same precedence, if they appear in an expression, then what is to be done? Right? This is resolved using something called as associativity. This basically tells the order of evaluation of these expressions, whether they have to be evaluated from left to right or right to left. So whenever we have more than one operators in a particular expression with the same precedence, the order of the evaluation determines to evaluate the expression. So in this case, these are evaluated from left to right. So when I go from left to right, it is the multiplication that appears first. So I perform 12, then I perform division operation, the result of which is 6. Right? So the associativity defines the direction. Precedence defines the priority. Associativity defines the direction. right? Whether left to right or right to left, in which the operators act upon the operands. Okay. Multiplication and division, they have the same precedence. As per the associativity, division operation will be evaluated followed by the multiplication. For example, in this, division is performed first and then the multiplication. There are many operators, as we have discussed in a previous video, that are available in C language. Now each of these operators have their precedence and associativity, right? So this table lists the precedence in the order of higher priority, that is the first row of the table has the operators with highest precedence, lesser precedence than the first, and so on. So your parenthesis, array, postfix operators have the highest priorities, okay, and in the order, comma has the lowest priority, right? When these operators, when a group of operators of the same priority appear in an expression, right, then we apply the rules of associativity. As discussed in the previous example, star, multiplication and division, they have the same precedence. In that case, if at all they appear in an expression, we apply associativity rules, right? Okay. Now let us take an example. Determine the value of n, right? How does this go? First, observe the operators. We have minus and we have into. We have a subtraction operator and a multiplication operator. Okay, multiplication operator has highest precedence when compared to your subtraction operator. So the operands with respect to multiplication are evaluated first. Okay, so we get 5 minus 2 into 7 is evaluated first, 14 minus 9. Then minus and minus both have same precedence, correct? So they will be evaluated from by applying the rules of your associativity, that is left to right. Okay, so how will this go now? 5 minus 14, right, minus 9. So the result will be minus 18. Okay, now also remember, equal to is also an operator, and in the table, if you observe, assignment operators have the lowest priority. That means always the assignment is done at the last. That is assigning your right hand side value to your left hand side, right? Okay. Explain the evaluation steps for this expression w equal to x into y into z. So as per our precedence and associativity table, parentheses have the highest priority, then comes your multiplication, then comes your equal to sign, right? So what should be done now? We have to evaluate y into z first. This is the first step, correct? Then we have a multiplication operation. To this we have to add, let me call this as r1. This is multiplied with r1. Now this result, let me call this as r2. So your w is assigned with r2. This is how the evaluation goes. Okay. Alright. Now one thing to remember, always it is difficult to keep that bigger table in your mind. So you can remember this instead of remembering the entire table. First thing, there are certain operators that are considered as primary operators, that is the operators with high precedence. Those are the parenthesis, arrays, dot operator and an arrow operator. All of these have same priority and they have the highest priority than any other operators of the language. One thing. Second thing, based upon the number of operands, based upon the number of operands. We all know there are unary operators, binary operators and ternary operators. Okay, priority wise also the unary operators have the highest precedence, then the binary operators, then the ternary operators. So only if you observe in the table, unary plus, unary minus, increment, decrement have the highest priority, then comes your arithmetic operators, then comes your conditional operators. Okay, and assignment operators, they have the lowest priority, that is the right hand side expression is evaluated first and that is assigned to your LHS. So assignment operators have the lowest priority among the operators. Right? So you can remember this instead of remembering the entire table. Okay. Let us take a few examples based on precedence and associativity. So the first one, x is equal to 2 into 3 plus 4 into 5. Okay, how is this evaluated? So as discussed, here the operators are plus and equal to. Plus has highest precedence, then comes the plus, then comes the equal to sign. So how is this evaluated? You will have 2 into 3 as well as 4 into 5. So 2 into 3 is 6 plus 20 plus on 6 and 20 we get 26. Next, x is equal to 2 into 3 plus 4 into 5. What are the operators here? We have parenthesis, multiplication, addition and equal to. So parenthesis has higher priority, then multiplication, then an addition. So intermediate step will be 2. First evaluate 3 plus 4, 7, to that 5. So now whenever we have same precedence operator, they will be evaluated from left to right. So it will be 2 into 7 into 5, that yields 70. So x will be assigned with 70. Next, 7 into 6 mod 15 divided by 9. Now if you observe here, we have multiplication, division, modulus and equal to. All of these have, yes, all of these have same precedence. Now how this should be evaluated? This should be evaluated from left to right. So it will be 42 mod 15 divided by 9. So 42 mod 15 again, right? That divided by 9. Yes, that will give me the answer as 1. Yeah. 7 into 6 mod 15 divided by 9. However, 6 mod 15 is put into a parenthesis. Okay, so 6 mod 15 is evaluated first. I get the answer as 6. Then I have 7 into 6 divided by 9. 7 into 6 is evaluated first. 42 divided by 9. That will give me answer as 4. Right? Next, 7 into 6 mod 15 by 9. Okay, so again parenthesis is there. So this is evaluated first. 15 mod 9 will give me the answer as 1. Then 7 into 6 mod 1. Right? So this will give me the answer as 0. 42 mod 1 will give the answer as 0. Next, 7 into, in bracket, again we have grouped 6 mod 15 in one bracket, this divided by 9. So this will be 6 divided by 9. To that we are multiplying 7. So this will give me 0. Since this is 0, 7 into 0 will give me 0. Right? Now what happens to this expression? We have z is equal to, x is equal to 3 into 4 divided by 5. So here since this is put into a parenthesis, this will be evaluated first. X will be assigned with the value of 12. 12 divided by 5, the answer will be 2. Yeah, x is equal to y is equal to z is equal to 3. Now what happens in this case? Right, whenever you have equality, multiple equal to operators, the order of evaluation is right to left. So 3 will be assigned to z first, 3 will be assigned to z, right? That 3 will be assigned to y, so y becomes 3. Now that value will be assigned to your x, so the final result will be 3. Okay, now here z is equal to 3, right? If at all you don't want the confusion, you can put the same expression in parenthesis, right? Now coming to your R values and L values. So these L values, your basically an LHS is called as an L value, which is located on a left hand side of your assignment operator. R value is located on your right hand side of your assignment operator. One thing you have to remember, your L value cannot be a constant. For example, you cannot have 1 is equal to x. No, it should be a placeholder. Your LHS should be a placeholder. It should be a variable. You cannot have x plus y is equal to a plus b. Wrong. Okay, you cannot have x plus b is equal to 5. This is also wrong. You should have a variable is equal to an expression, because a variable is supposed to store the result of this expression. Okay, all of these will generate a compile time errors, right? Coming to type conversions in C, how the type conversions takes place. So evaluating the expressions results a value. Now obviously that value, it also has a data type, right? Now if all the variables in an expression are of same type, the resulting type will also be same. But however, this does not happen always. There will be changes in the variables in an expression, right? For example, I have int a, right, float b, right? I'll have one more variable here, z. Now I will have z is equal to a divided by b. The data type of a is int, data type of b is float. Now the question comes into picture, when I evaluate this expression, what should be the data type? Okay, how the type conversion happens? Or why the type conversion is essential, right? So whenever the variables in an expressions are of different type, type conversions takes place. Now there are two types of type conversion. One is implicit type conversion, which is taken care by your compiler based on some rules. Okay, compiler based on some rules. These type conversions are also called as an automatic type conversions. Okay, the other type is explicit type conversion, wherein a programmer has the control over which variables he wants to convert the type, right? We'll first discuss about implicit type conversion and then discuss on explicit type conversion. Implicit type conversion, as I discussed before, this is taken care by your compiler. So here the conversion is from smaller to larger type, based upon the size of a particular data type. So as we have discussed in our previous videos, the various data types supported by C, okay, and all of them have a certain amount of storage in bytes. So if you observe the hierarchy, you have character which occupies 1 byte, then comes the short 2 bytes, integer 4 bytes, then comes the unsigned int 4 bytes, long int 8 bytes, and so on. Okay, so in an expression, if there is an integer, and if there is a character variable, right? So whenever the expression gets evaluated, okay, this character will be promoted to an integer. So resulting result will be of integer. Such type of conversions are called as promotion. They are called as promotion, wherein a type of a smaller data type, a type of a smaller variable is converted to its higher. Why it is done? It is done to match the type of other operands in an expression. Okay. So the first is conversion of smaller to larger type. It's based upon your size. For example, I have the variable c declared as char, integer j, float f, and d and r are of double type. Now let us evaluate this expression. R is equal to c into j plus f divided by j minus f into d. Right? Now, so parenthesis will be evaluated first as per our precedence. Correct? So c into j. C is of character and j is of integer. Smaller type is promoted to the higher type, right, to match the type of the operands. So this is promoted to int. Correct? This is already int. The result of this evaluation will be int. Here f is float, j is int, smaller type is promoted to float, so j is promoted to float. So I evaluate this, I get the result as float. Here f is float, d is double, f is promoted to double, evaluate it, I get the result as double. Right? Now I have, what all I have now? Plus, let me call this as R1, let me call this as R2, and let me call this as R3. Right? Now plus and minus have same precedence. Order of evaluation will be from left to right. So here I will be evaluating a float result with an int. Again, automatically the type conversion takes place from int to float, float plus float, resulting into float. Now to this I need to subtract a double result, right? Type conversion takes place, this will be double, double minus double will yield me double. So finally R will have a data type of double. So this is basically called as automatic, or it is also called as implicit type conversion, which is taken care by your compiler. Right? Again, there are other rules, we shall have a discussion on the same. Conversion by assignment. So as we saw in this example, there was promotion taking place, that is from a type of a variable it was promoted to its higher type. However, when you observe in an assignment operator, whenever we are assigning an RHS R value to an L value, demotion might also takes place. Right? For example, I have declared a variable f. I have declared a variable f as float and I as int. Now, whenever I try to assign an integer to a floating point value, there will be a promotion. Let me take an example here. This f is a float, integer is 4. So, whenever I assign f is equal to 4, this will be stored as 4.000000. What is happening here? Your integer variable is promoted to float. But what happens in a reverse way? If at all I have f is equal to 4.321 and this value I am trying to assign it to an integer, right? Here a demotion takes place because there is an assignment operator. Okay, here I am trying to assign a float to int. Okay, what happens in this case? There will be a demotion. So here your value will be just 4. right? So you have to remember one thing, whenever we perform assignment operator, right, whenever we use assignment operator and there is a demotion taking place, there will be a loss of value. Okay, some more examples on implicit, or some more rules on implicit type. Conversion of characters and integer. So whenever we have type conversion taking place from short int to long int, there will always be a sign extension. Okay, there will always be a sign extension. So whenever we are assigning an unsigned to a wider unsigned, like unsigned short int to an unsigned int, right, there will be a 0 extension. Now whenever we have a lower data type, as we discussed previously in an assignment operator, there will be a truncation, there will be a bit preservation when we deal with signed and unsigned numbers. Okay, there will also be hardware manipulation for internal conversion, and truncate at decimal point for floating point numbers. We'll just have an example for this. Short int will declare few variables, short int as si, long int li, unsigned int usi. Okay, unsigned long int uli and si is assigned to -10. We'll just have a look at the values, what will be the state here. When I assign a short int, okay, when I assign a short signed int to a long int, what happens here? There will be a sign extension. There will be a sign extension. Next, when I have an unsigned decimal constant, this is how we write an unsigned decimal constant. A constant preceded with u. This indicates it's an unsigned decimal constant. Right? Now when I assign that to unsigned long int, okay, there will be a 0 extension because there is no sign. So zeros will be added. Now when I have something like this, unsigned long int is assigned with a hexadecimal constant. Okay, when that is assigned to your short int, unsigned short int, okay, your higher order bits will get truncated, higher order value will get truncated. So only value that will be stored is EF12. Okay, similarly when I assign an unsigned short int to a signed int, right, so there will again be only bit patterns, lower order bits will be preserved, right. So these are for your characters and integers with respect to various short, long and so on. Now what happens for conversion for float and double? Alright, so in C all the floating point constants are implicitly double precision until and unless you explicitly specify, right. So operations involving such constants takes place in a double precision format. Conversion for floating and integral type, whenever a floating point is assigned to an integer, the decimal portion gets truncated and the integral part is stored. Alright, so assigning an integer variable to a floating point, it does not cause any changes in the actual value of a number. So only thing you have to keep it in your mind whenever we assign a floating point to an integer. Alright, okay, this is a small example here. Yeah, I've assigned I with 1400. Okay, it's an integer variable, and I'm trying to assign I to x, where x is a double. So when I perform this, a promotion takes place, that is I is promoted to double, okay, and the decimal part will also be printed. However, when I try to assign x to I, when x is 14.99 and I try to assign x to I, here a demotion takes place from double to int, okay, and the decimal part is lost, right. Now let us take x is equal to some large number, that is 1 e to the power of 60. Okay, it's a pretty large number, and this number I'm trying to assign it to I. I'll get some garbage value, right. We'll just run this program and just check it out. Yeah, x is equal to, yeah, here the promotion has taken place when I is equal to 1400. When I assign it to x is a double precision format, so I get something like this. X is equal to 14.999 and so on. When I assign that to I get it as 14. The decimal part is truncated. Alright, when I try to assign a pretty large number to a integer value, I get some garbage value. Okay. Now apart from this, a programmer also has a facility to explicitly provide the type conversion. Right. So this is called as explicit type conversion. Okay. We do this explicit type conversion to forcefully have a promotion. Right. So one thing to remember, explicit type conversion is done by the programmer and not by the compiler. The syntax for performing that, or to have an explicit type conversion, is data type, which is provided in parenthesis followed by a variable name. For example, I have I, okay, which is declared to be int, float j. Okay, now explicitly I am specifying I to be taken as float. In this case, the data type of I will not be modified in the memory, but a copy of I is taken, which is stored as its floating point value. Okay, so internal copy of a variable I is done, and then it is assigned to your floating point variable. Yeah, so usually explicit type conversions we do it when we are dealing with a division operator. Okay. Yeah, we'll just have a look at one example here. Okay, here value of A is 100, B is 40, and I have taken C to be float. Okay, C to be float. Now we cannot have appropriate implicit type conversion here, because when I perform A by B, both are of integer operands, so the execution is pretty fine for a compiler, right? But however, when I perform this division operation, that is 100 by 40, I don't get the appropriate result. Okay, to have that appropriate result, what do? I will typecast one of the variable to float. Now what happens here, since B is forcefully typecasted to float, A will also be float, and this happens float by float division. I get an appropriate answer. Let me just run this program and check it out. So the value of C before type conversion it was 2. Okay, that 0.5 was lost because it was integer by integer division. Alright, now when I explicitly typecast it, I got the answer as 2 by 5. Okay, so this completes the discussion on type conversion. Thank you.